Due in part to the variables and job responsibility assignments from plant to plant, Kenyon recommends that all maintenance personnel study the videotapes on safety and housekeeping, the operator's job, and the computer tapes, in addition to this tape on preventive maintenance. This will enhance safe work practices, communications, and ensure coverage of maintenance personnel responsibilities at your plant. The specific configuration of Kenyon tenter frames may vary from plant to plant, depending upon process, fabric construction and width, the dryer heat source, operational data desired, machine floor space availability, and pre-entry and exit-in machines in line with the Kenyon tenter frame. Not only is Kenyon able to meet the manufacturing requirements of each individual customer, but each of its tenter frames meets OSHA standards and are approved by the underwriter laboratories and industrial risk insurers. Still, all personnel working on and around electrical or mechanical equipment should use caution and common sense. The efficient operation of the Kenyon tenter frame, as with any electrical or mechanical piece of equipment, requires not only the immediate attention to all identified problems, but also an effective preventive maintenance program. Since all maintenance work must be done in accordance with manufacturer's recommendations and in agreement with OSHA requirements, we will begin this video training with lockout tagout procedures. Before performing any maintenance service to any moving part of the machine, its electrical elements, or entering the dryer, you must first lock out and tag out the main electrical power source to the tenter frame. Go to the electrical enclosures cabinet while the machine is in a stopped mode. Pull down on the on-off handle, moving it from the on position to the off position. You can now apply your lockout tagout device to the handle. Each person working on the tenter frame will then place his or her lock on the device, lock it, and remove their key and take the key with them. Once an individual has completed their work, they unlock and remove their lock from the device. When all locks have been removed from the device, the lockout tagout device itself can be removed from the handle. Push the handle back up to the on position when it's time to restore power to the machine. Should one or more of the electrical enclosure cabinet doors not be fully closed and latched, it will not be possible to move the handle to the on position. Only after closing and latching all of these doors can you restore power to the machine. This is another built-in safety feature of the Kenyon tenter frame. Again, never perform any maintenance or cleaning task on any moving part of the tenter frame or dryer, or enter any dangerous area without first locking out and tagging out the main power source. This naturally holds true when working on any pre-entry or exit-in machines that are in line with the Kenyon tenter frame. Following the plant's lockout-tagout program is not an option. It is mandatory. Emergency stop buttons and cables are strategically located throughout your tenter frame regardless of its configuration. Periodic scheduled testing should be performed to assure that each and every emergency stop button and cable does in fact function as it should. Corrective maintenance is to be done immediately upon finding a non-functioning emergency stop button or cable. Emergency stops will abruptly stop the tenter frame and are to be used primarily for safety purposes. Excessive use of the emergency stops may cause damage to the mechanical components of the tenter frame. To avoid any possible damage to the machine, Kenyon recommends that testing of the emergency stops be done while the tenter frame is in fact stopped. Normal stop buttons are located on the front operator's console and the rear operator's consolette. As the name implies, normal stops are to be used during routine operations. Normal stops will bring the tenter frame to a smooth, controlled stop without any damage to the machine or fabric. All electrical maintenance is to be performed by trained qualified electricians only and is to be done in accordance with manufacturer's specifications. Qualified electricians know that they are never to bypass any electrical safety. Once the electrician has completed his or her task, they are to close and latch all doors to the electrical enclosures cabinet in order to restore power to the tenter frame. This will also prevent access by the curious and untrained to a dangerous area. There are two types of motors used on the Kenyon tenter frame: AC constant speed motors and AC adjustable frequency duty rated motors controlled by AC adjustable frequency drives. Your tenter frame may or may not have all of the motors we are going to discuss, but the principles will remain constant and apply to those motors which your frame does have. AC constant speed motors power the spreader rolls, the hinge rail guider system, with screws outside the dryer and inside the dryer. On frames which use a thermal fluid heat source, the motor that powers the thermal fluid heat gate damper which controls the heat exchange, and on gas-heated dryers, there is an AC constant speed combustion blower motor for each burner, which is activated when the burner is on. On top of the dryer, AC constant speed motors power the heat exchange gate dampers and the make-up air dampers. Whether you have one or two fans on the freestanding air cooler, the motor or motors will also be AC constant speed motors, as will the motors for the selvage knives, the selvage trim ejectors, and the pin chain cleaning brushes. All of these motors operate at a constant preset speed. All components of the Kenyon tenter frame, which can be operated at different speeds, will derive their power from AC adjustable frequency duty rated motors. The AC adjustable frequency duty rated motors are driven. That is, their speeds are controlled by Magnatech AC adjustable frequency drives, which are in turn regulated in the manual operating mode by the 196 microspeed controls, or, as is most likely the case, by speed settings programmed into the computer. Minor speed control settings may be made during a run cycle using either the 196 microspeed control or by making changes in the computer program recipe through the use of the Adjust Set Point feature. Should you have a patter unit at the pre-entry end of the tenter frame, its speed will be determined by an AC adjustable frequency drive controlling its AC adjustable frequency duty rated motor. In addition to the patter, the following are also driven by AC adjustable frequency duty rated motors: the first or bottom overfeed draw roll, the top overfeed draw roll, the pin on wheel assembly, the pin chain, the entry fabric support conveyor belt system, the fabric removal wheel at the end of the frame, all top and bottom circulation fans, the exhaust fans, and the stripper roll. All motors, AC constant speed, and AC adjustable frequency duty rated, should be kept free of dust and lint and maintained in accordance with the manufacturer's specifications. Air conditioners are located on the right side, left side, and on the top of the electrical enclosures cabinets. Also on the front operator's console and the rear operator's consolette. These air conditioning units are there to prevent excessive heat buildup around the electrical or electronic components encased in these cabinets, and must be functional at all times. Their effectiveness is reduced when the filters are dirty, and therefore the filters must be regularly inspected and cleaned as necessary. Any service performed on the air conditioning units themselves must be done in accordance with the manufacturer's specifications. You will find air ventilation screens located on the front gear enclosure, the rear gear enclosure, and the freestanding air coolers. These screens must be kept free of dust and lint to permit the free flow of air. The purpose of these screens is to reduce the entry of dust and lint particles into the enclosures. Dryer recirculation screens should be cleaned as part of normal operations on a schedule consistent with the tight fabric being run and its lint production. Screens which are torn or broken should be replaced immediately. The free flow of air over and under the fabric will definitely enhance the drying of the fabric and reduce operating cost. Procedures for cleaning the dryer recirculation screens and inside the dryer are to be found on the video training tape entitled Safety and Housekeeping, which you should have studied prior to viewing this tape. There are two types of fabric support systems. The tension wire support system, which requires very little attention other than making sure that the weights are in place and the wires are clean. The other is the fabric conveyor belt system, which is often used in conjunction with a fabric steaming system. Where steam is a factor, you must be sure that the pulley drive shaft is kept properly oiled to prevent rusting. Proper tension can be restored to sagging belts by cutting off an appropriate length of the belt and then reconnecting it. Follow manufacturer's recommendations when lubricating fittings. This is the first or lower draw roll gear motor drive system, consisting of an AC adjustable frequency duty rated motor and its gearbox. You will need to check the gearbox for proper oil level as specified in the manufacturer's literature. Going across, you see the bottom overfeed draw roll and the tendency-driven roll. Behind this safety cover is where the tendency-driven roll gets its drive from. This safety cover prevents anyone from reaching inside the power transmission which drives this tendency roll from the first overfeed draw roll drive system. Your machine may or may not have this configuration. Now let's examine the drives for the fabric entry roll system. Your gear enclosure components may vary from these. For example, you may have one spreader roll, or you may have two spreader rolls. You may have one, two, or no skew rolls. But the principles we will discuss will remain the same. This AC constant speed motor drives the bottom spreader roll by a V-belt, and from it, another V-belt drive to the top spreader roll. Depending upon process, your tenter frame may or may not have a tendency-driven roll. If you do have a tendency-driven roll, this chain system drives the tendency-driven roll from the top overfeed draw roll AC adjustable frequency duty-rated motor and shaft-mounted gearbox. Here you see the shaft from the top overfeed draw roll, which drives down to and around these sprockets to get the proper rotation on the tendency-driven roll. This is a shaft-mounted reducer. Check the manufacturer's literature for recommendations on gearbox lubrication. Check the V-belts for tightness and signs of wear, and replace when necessary. Check the chain for wear and tightness, and lubricate as recommended by the manufacturer. This is the same gear enclosure as viewed from the other side. Here is the adjustable frequency drive for the top overfeed roll. As you see, we have a V-belt drive system up to the shaft-mounted reducer. Remember to maintain proper oil levels in accordance with the manufacturer's literature. On the inside of the shaft, you have a sprocket, which actually drives the tendency-driven roll through this power transmission chain. Frequently, throughout the tenter frame and dryer, you will find flange bearings or pillar block bearings, which must be maintained and lubricated in accordance with manufacturer's recommendations. This is the AC adjustable frequency duty rated motor that drives the stripper roll. We have a V-belt drive going up to the shaft mounted reducer, mounted on the stripper roll shaft. Inspect the V-belt for proper tension and signs of wear and replace when necessary. Check the oil level of the shaft mounted reducer and maintain in accordance with manufacturer's specifications. From the reducer drive is another V-belt going over to the tachometer, which in this example is in place for an automatic batcher in line with our tenter frame. This V-belt should also be inspected for tightness and wear. If not in good shape, it should be replaced. In the back, coming off of the stripper roll shaft, you see a power transmission chain which drives the tendency-driven idle roll. Check this chain and the bottom of the cabinet for metal filings and any belt residue due to misalignment or improper lubrication, and make necessary corrections. This AC adjustable frequency duty rated drive motor moves both the left and right pin chains. You may have separate drives for each chain. On our machine, we have a V-belt drive going up to the shaft mounted reducer, which is mounted onto the chain wheel drive shaft. This reducer also needs to be checked for proper oil level in accordance with manufacturer's specifications. This AC adjustable frequency duty rated motor drives the pin-on-wheel assembly, which consists of a bristle brush and a vulcanized rubber wheel. Check the condition of the bristle brush and replace as necessary to maintain proper pinning of the fabric onto the pin plates. Also replace the vulcanized rubber wheel as needed. This is another bristle brush after the pin-on-wheel assembly brush, which is a free-turning fixed position brush that augments the fabric pinning of the first brush. It and the smaller vulcanized rubber press roll under the fabric should be checked and replaced as required. During routine maintenance, the wire brush of the pin chain cleaner should be checked and replaced if needed. This brush is driven by an AC constant speed motor and is positioned to clean the pin plates of fabric finishes, resins, lint, and selvage trim waste. Cleaning of the pins should be done while there is no fabric on the machine. We suggest that you review the Safety and Housekeeping video segment on pin chain cleaning for more detail. Checking for metal filings and belt residue in the bottom of the front and rear gear enclosures, and at all locations where there is movement of machine parts such as gearboxes, sprockets and chains, shafts, belts, and the fabric pin chain will provide a quick reference to misalignment and improper lubrication. Naturally, you should take corrective action where needed. This is an excellent area to inspect the pin chain for proper lubrication and filings. Tension on the pin chain is maintained by air pressure to the pneumatic cylinders, and this is done at a constant 80 psi. Typically, as in this example, pin plates are attached to the pin chain by two 1/4 inch screws. These are needle-sharp pins. If these pins are blunt, bent over, broken, or missing, the pin plate must be replaced. Salvage trim waste, lint, finishes, and resins tend to build up on the pin plates. This buildup must be removed to ensure proper pinning of the fabric onto the pin plates. Regardless of whether or not your tenor frame has the optional hinged pin rail cover, you should remember to keep the mispin sensors clean and functioning properly. The pin chain on the right and the pin chain on the left may be driven by the same AC adjustable frequency duty rated motor, or they can be individually driven by two separate AC adjustable frequency duty rated motors. And when you have the two separate AC adjustable frequency duty rated motors, this is referred to as split tenor control. Whether or not you use two separate drives can best be determined by the amount of fabric bias control that you need to exert prior to heat setting the fabric. On this machine, there are 3 driven draw rolls. 2 are overfeed draw rolls, the first or bottom overfeed draw roll and the top overfeed draw roll. The third driven draw roll is the stripper draw roll. Each of these draw rolls is covered by a rubber wrapping which must be routinely checked for wear or tears. To ensure that we have proper gripping of the fabric at these draw rolls, we must repair or replace any damaged covering. Again, depending on the construction of your Kenyon tenor frame and pre-entry equipment, you may have 2 or more tandematic decurlers. In either case, they should be kept clean and maintained in accordance with manufacturer's specifications. The width of the entry end of the hinged pin chain rail is controlled by a sensor on both sides of the tenor frame immediately prior to the pin-on assembly. These sensors measure the depth of the pin-on of the fabric, and by activating the rail guider system, it causes the rail to move inward or outward to accommodate the fabric width to the pin-on assembly. Here we are using a Earhart-Lamer KRA50 rail guider system. You may have any of a variety of systems which is most appropriate for your tenor frame. In our example, the Earhart-Lamer KRA50 has a pinion mounted on the end of the motor, which when turning engages the rack, thus moving the rail in or out. Regardless of your hinged rail guider system, the principle remains the same. There are limit switches mounted on the rack to prevent excessive spread or narrowing of the hinged rails. There is also a limit switch on each side of the hinged rail just prior to the first width screw. This prevents excessive spread of the rails at this point. There are additional limit switches for other purposes located throughout the tenter frame and dryer, such as the proximity switch on the first width screw and the smart eye sensors inside the dryer. Each of these prevent excessive outward movement of the width screws. You will also find limit switches on the top of dryers which use thermal fluid for their heat source. These limit switches prevent the heat exchange dampers from moving too far up or down. All of these sensors and switches must be maintained in keeping with manufacturer's specifications. The majority of Kenyon tenter frame dryers use natural gas burners for their heat source. This is the exterior portion of the Maxon 405 natural gas burner assembly, located at each heater zone. This unit should be kept free of lint and dust at all times. Special attention should be given to the combustion blower motor and fan during the cleaning cycle. This actual burner inside the heater zone must also be kept clean. During your regular scheduled maintenance and cleaning cycles, be sure to clean the gas ignition plug, the flame rod, and the gas ports, as well as the walls of the burner. Should there ever be a gas leak, immediately turn off the main gas supply to the dryer and shut down the dryer until repairs are complete. Maintenance personnel should use the Check for Gas Leak button when doing routine maintenance on the gas burners. Some Kenyon tenter frames use thermal fluid as their heat source. The thermal fluid is a heated oil. The thermal fluid is piped into the dryer, and the air inside the dryer is heated as it flows across the fins of the thermal fluid pipes. The degree of heat exchange that takes place is controlled by the heat exchange dampers. As they open or close, more or less air is allowed to flow across the fins of the thermal fluid pipes. During maintenance and cleaning cycles, these heat exchange fins must be cleaned of lint for efficient exchange of heat to the air. Check for signs of any fluid leaks and repair as needed. You should also check the condition of the damper seal and repair or replace as required to ensure proper closure when the damper is in the closed position. This is the constant speed motor and reducer for the first width screw and is typical of all independent width screw drives. Lubrication of the reducers and care of the motor must be in accordance with the manufacturer's recommendations. Routine removal of lint, fabric string waste, and salvage waste from the screws will prevent jamming at the nuts, which would cause a malfunction of the width control system. Use a dry lubricant on the width screws themselves. Be sure to keep the proximity switch and smart eye sensors clean to assure proper functioning. Width screw power transmission chains inside the dryer must be kept free of lint and salvage waste. Lubricate with a dry lubricant in accordance with the manufacturer's recommendations and maintain proper tension on the chain. Here is the AC constant speed motor and reducer for the last width screw drive. The reducer is typical of the shaft-mounted type. Inspect and maintain the proper oil level in the reducer as directed by manufacturer's literature. Notice too the pillar block bearings on each side of the shaft coupling. These grease fittings are also to be lubricated in accordance with the manufacturer's recommendations. Check the coupling for signs of wear or misalignment. In this portion on width screw calibrate, the principles will remain constant, although not all tenter frames have this configuration on the operator's console. Anytime this width overload light comes on, the operator is to immediately notify maintenance personnel and to press the width emergency stop button, which will prevent any change being made in width settings either manually or through the computer. Simply pressing the width emergency stop button will illuminate the overload light. In order to recalibrate the width, first check for and correct the cause of the width overload. Pull up on the width emergency stop button, remove all fabric from the frame. Press the green start button. This will force all widths to go to their maximum widths, and this stop button will light, indicating that the widths are ready to be reset. Manually, each width reset button on the Microspeed 196 processors must be depressed for a minimum of 3 seconds to reset the width. Once all widths have been reestablished, replace the fabric on the frame and continue the operation. This is the AC constant speed motor for the selvage trim knife system. Behind it is a gearbox which can be raised or lowered to position the knife assembly in relation to the pin plates transporting the fabric. Check and maintain the proper oil level in the gearbox in accordance with manufacturer's literature. This radial pin wheel has 2 rows of short radial pins which must be maintained at their proper sharpness. If they are bent or broken, the radial pin wheel should be replaced. The blade of the selvage trim system must be kept sharp and is not to be sharpened on the machine. Rather, it should be taken off and sharpened in the maintenance department shop. Remember to check for any vibrations of the unit. The AC constant speed motor for the selvage trim system should be routinely cleaned of dust and lint. The air intake bell keeps the motor cool during operation. This system removes the trimmed selvage to a collection roll or bag. The air pressure on the pin chain oiler system is to be kept at a constant 80 psi at all times during operation of the tenter frame. As part of normal maintenance, check the air hoses to both pin chain oilers for any crimps or leaks. Also remember to empty the water collection bowl as needed and to keep the air system oiler bowl to the proper level. Oil in the pin chain oil reservoir must be kept at not less than half full. As the oil is being applied to the pin chain, these oil injector pins will be extended. This gives a visual indication that oil is in fact being applied to the pin chain at that moment. Be sure to turn off the air to the system prior to performing any maintenance other than draining the water collection bowl, filling the system oil bowl, or filling the pin chain oiler reservoir. All maintenance is to be done in accordance with manufacturer's recommendations. The frequency at which oil is being applied to the pin chain is indicated on the oiler meter located on this operator's console, and its readout is in yards. It is preset by Kenyon technicians and should be changed only by authorized maintenance personnel. In the event that there is a problem with the counter or electrical system, this check oiler system light will illuminate and maintenance personnel must be notified. Never operate the tenter frame with this light on. Again, all maintenance on this system must be done as directed by manufacturer's literature. In addition to all of the built-in safety features of the Kenyon tenter frame, you, as a professional member of the maintenance team at your plant, know that anyone working around electrical or mechanical equipment must use caution and common sense while performing their duties. We have stressed the need to follow the lockout-tagout procedures, wearing of protective gear for your benefit, and also knowing and following the recommendations of the manufacturers in performing maintenance on any of the operational components of the Kenyon tenter frame. As a professional member of this plant's maintenance team, you know that no machine can run very long without proper lubrication. You also know that the cleaner a machine is kept, the better it runs, and the higher its quality of production. You know to check for filings, vibrations, and alignment of parts, to look for worn or broken parts and to repair or replace as needed, to keep proper tension on chains and belts regardless of where they are. You also know to have every nut, bolt, and screw under proper torque. You know too that doing it right the first time makes your job easier and more rewarding. So we wish you, Mr. or Ms. Professional, a long, safe, and successful career here at this plant.